Now let's see the third law of logarithms. The third law says that this is m log x to the base a. So the power inside the log comes out as the base when it comes out of the logarithm, is what we're going to prove as the third law of logarithms using the exponents. So we have already taken that x is a power n. So using this, immediately when I convert this into the logarithmic form, I understand that this is n is log x to base a. When I convert this exponent to logarithmic form, I have n equal to log x to base a. Now, that implies, because I need x power m, I'm going to raise this x to power m so that equally on the right, this gets raised to power m. And this would be nothing but a power nm. Both the powers get multiplied, but this doesn't become n power m. Most of them do the mistakes out there. So this is a power, this is a power. So the powers get multiplied. So n times of m is a power nm. That implies, finally, I get x power m is a power nm, so that when I convert this exponential to logarithmic form, a equal to b power c, then log x power m, this forms the base. So to the base a will directly be equal to nm. This forms on the right hand side. This goes to the right hand side. Therefore, this exponent gets converted to the logarithmic equation as log x power m to the base a equal to nm. Now this in turn, when substituted, gives me that log x power m to the base a is n. What is n? I have n as log x to the base a times of this m is as it is, because I don't have any value for m. I just straight away take m in the next step. Now this, when rearranged with the terms, gives me log x power m to the base a is m log x to the base a, thus proving the third law of logarithm using the exponents connected with logarithms. So finally, I can conclude saying that the third law of logarithm states that log x to the power of m to the base a is m log x to base a. It is a very important formula in mathematics part. Now, I wanted to find some of the logarithmic problems using the different properties as we have identified, especially the three laws of logarithms. So when I wanted to find, say, the log of 343 by 125, then I just use some of the properties here. Clearly, this is in the form x by y. So my second law of logarithm says that log x by y is log x minus log y. And therefore, this can immediately be written as log 343 minus log 125 is how we understand. Now, one important thing out here in this question is that there's no base given. So remember, when there's no base given, we understand that this is referred as log to the base 10. When there's no base given, we understand this as to the base 10. So we don't need to put the base, indirectly assumed as to the base 10. So this being log 343 to the base 10 minus log 125 to the base 10 can further be simplified, because 343 can be written as 7 cube minus log 125, which can be written as 5 cube, which on further simplification using the third law of logarithm says that log x power m is m log x. Therefore, this m comes out, this 3 comes out, 3 log 7, 3 log 5. Minus log 5. So I have to just simplify them using the different types of logarithmic properties, and then simplify further, finally to get the answer. This cannot be simplified further. So this is assumed to be the final answer for the given problem. Now what if I give this and ask you to find this, the reverse process? Can we do that? Is what we're going to see in the next example. Say for example, this is my question. I want to simplify this as a single logarithm where I have to simplify all these values. It's quite simple because here I'm going to go in the reverse process of using the formulae. If my log x power m is m log x, then my m log x is log x power m. Therefore, my m log x becomes log x power m, written as 3 raised to 2, minus 4 log 2 can be raised as 2 power 4. And this remains as it is as log 5, which can be further simplified. Now this clearly makes me understand that log a minus log b is log a by b, the second law of logarithm. Therefore, this can be written as 3 square by 2 power 4 as using the second law of logarithm, plus log 5 remains the same. So in this case, when I further simplify this, I get this to be log a plus log b as log ab, the first law of logarithm. Therefore, this can be written as 3 square by 2 power 4 times of 5 using the first law. Then finally, I simplify this answer so that I get 3 square is 9 times 5, 2 to 4, 4 is 16, so that this reduces as a single logarithm. 45 over 16 is the single logarithm value for the given problem. So we can do either by converting the single logarithm into split form or the split logarithm into the single logarithm form by just using the properties, especially the 3 laws of logarithms.